Welcome everyone in our virtual classroom. This is the 25th lecture on engineering mechanics. Here I am going to discuss the numerical problems and its solution on sliding ladder, a falling ladder, when a ladder is sliding and when a coin is rolling in a straight path. So these two different types of numerical I am going to discuss. Let's follow the lecture.
In the chapter of friction, we have discussed about the static condition of ladder. But when a ladder is slipping or falling, then it is in kinematic motion. And the motion is two-dimensional. Generally, it is in vertical plane. So, planar motion, two-dimensional motion means planar motion. Now, we will discuss about the falling ladder. The length of the ladder is given, and for a particular instant, the angle theta is also given. That we have to find out what's the omega, the absolute velocity, acceleration of the ladder. At that particular instant, when the theta is 60 degree, the omega value that is given, the angular velocity is given. Now, when it is falling, we can consider that there is a 2 point, and point A is always in contact with the vertical wall, and the point B is always in contact with horizontal floor. So while motion, point A is moving down and point B or end B of the ladder is moving left. If the leftward direction is considered as the unit vector is I and the vertical direction is J, unit vector is J, and perpendicular to this plane, the vector is K. Now, what's the given data? The omega vector is given. The magnitude is 1.15 radian per second. What's the direction? We know the direction is perpendicular to the plane of rotation. So what's the plane of rotation? Ij, or this Ij is the plane of rotation. In that case, the direction of omega is perpendicular to Ij, means in the k direction. So it is omega k, where this omega is the magnitude and k is the direction, and this is the angular velocity vector. Likewise, the alpha, angular acceleration of the ladder, that is also alpha equals to alpha k, and for that instant when theta equals to 60 degree, the value of alpha that is given 2.5 radian per second square. Now we have to find out the absolute velocity and acceleration of point B of the ladder. What's the radius vector here? AB is the radius vector. To find out point B, let's consider the radius vector is RBA. The direction is toward B. It is the radius vector of B with respect to A. If it is RAB, then the direction was towards A. Now, as already I have told you, VA can be written as VAJ. Why? Because A is only in downward direction, means in J is the unit vector. So VAJ. What this bold letter indicates the vector, and the normal letter indicates the magnitude of the vector. So magnitude is VA. Now A is the acceleration of point A. Again it is downward. So J is the unit vector. In case of B, it is moving left, means in the direction of X, or unit vector is I. So BVI and it is AB equals to ABI. Now substitute this value of RBA, then it is equals to L cos theta I plus L sin theta J. Why it is so? It is the L. Now the component of this length in I direction, it is sin theta, whereas in the J direction, in this direction, it is the J direction, L, this is cos theta, means I direction, and this J direction, L sin theta. So this is the radius vector. Now to find out the velocity of point B, absolute velocity of point B, we know VB is equals to VA plus VVA. In lecture 1 we have derived this equation and explained, where VA is the absolute velocity of A and VBA is the absolute velocity of B with respect to A. Absolute velocity of B with respect to A. That is equals to omega RVA. Now VA equals to VAJ, that we have written here, and omega, that is equals to 0 0 k. No I component and j component, only k component is there. So 0 0 k. K is the omega is the magnitude. And for the radius vector, this is the vector where k component is 0. Now go through the cross multiplication and obtain this value of VVA. Now we can sum up the j components here. So from these VB is the absolute velocity vector for point B. To find out the angular acceleration of point B, I am starting with equation 1, that is VB equals to VA plus a relative velocity of, this is the relative velocity of point B with respect to A. Again we know VV direction is always in I direction, so VV can be written as VV equals to VBI. Already we have written this. Now substitute this value here and get this. Now as it is the velocity, so dotting both sides, we are having the velocity VB like this. Then what's the acceleration? Acceleration is equals to the absolute acceleration of A plus relative acceleration of B with respect to A. Relative acceleration of B with respect to A has two different components. One is the tangential component equals to omega into VBA. Here VBA is the this part of velocity, and tangential component is alpha RBA. Now substitute these values. A equals to AG, J direction acceleration, omega direction is perpendicular to the plane of rotation, so omega k. The VBA value is replaced from here. Alpha, that is also in k direction, so alpha k into the radius vector L cos theta I plus L sin theta j. Now similar to this method means dotting both sides by I and eliminating some of the terms, we are getting I cross I dot I equals to 1 means AB is there, and this is the K into I, K cross I indicates J. So J into I, that is 0. So that component is not there. Similarly here J cross K means I, and this I multiply with I, then we are getting this component. We have omega square L cos theta, and as K cross J, that gives minus sign. Simply go through the vector product here only, and then this K cross I again. So K cross I means J into I, so that is equals to 0, but this component is there, K cross J, again it is minus I into in dot I, that is alpha L sin theta. Now substitute the value of omega and alpha, and we are having the absolute velocity of B is 4.51 meter per second square. This is a problem of rolling cylinder. A cylinder is rolling on an inclined plane. The dimension of the cylinder is given, and the linear velocity V of the center of gravity or mass center is given as 0.5 meter per second, and the linear acceleration, that is also given at an instant. Then we have to find out the angular speed omega and the angular acceleration at a different time, at an instant t equals to 0. That indicates initially. What's the value? Initially means when the value of v is this and acceleration is this, and after that instant the absolute velocity will change, velocity and acceleration will change, as well as the angular acceleration also. Now within the time period of 2 seconds, how many revolution it will complete, and what is the total distance traveled by the mass center G. So these all we need to find out. So as usual, we will start with the given data. The given data, the diameter of the cylinder is given. Now from the kinematics of pure rolling. So what is pure rolling? Pure rolling means there is no relative motion, then there is no slipping. Means always a point is in contact with the body with the inclined plane. It does not slip, only rolls. Whatever friction is there between the cylinder and the plane is sufficient, so that there is no scope of slipping. So as per the condition of the pure rolling, initially the velocity is equals to omega 0 r. This omega 0 means the initial angular velocity that is given, and the radius is also given. So substituting we are getting the omega 0. Omega 0 is not, V0 is given, so we are getting the omega 0 value 2 radian per second. Similarly here absolute the acceleration A is given, A equals to alpha r. So A equals to alpha r, and that's why this is equals to, substituting the value of r, we are getting alpha equals to 0.4 radian per second square. Now what is the total distance traveled by the cylinder? As we know, for the linear motion, A is equals to ut plus half ft square. So similarly in the kinematics of a rigid body, that we have derived this equation where theta is the distance travelled, angular distance travelled by the cylinder, omega 0 initial velocity, angular velocity, alpha angular acceleration, constant angular acceleration if it is constant, then the time. Substituting all these values for the time 2 seconds, we are getting 0.76 revolution. This is radian, 4.8 radian equals to 0.76 revolution. So we obtain the number of revolution. Our next part is to find out what is the total distance. So we know total distance equals to S equals to V0t half at square. Simply substitute these values. V0, t means 2 seconds, a the acceleration, here we have calculated, and then we are getting the distance travelled is 1.2 meters. And in another way, we also can find out the same distance S equals to r theta. What is S? S means the total distance travelled, r means the radius, and theta means total theta revolution, 4.8 radian. So in both the way, we can use this formula or this formula. We can have the values. Our last problem today is rolling coin. The coin is placed on a plate, base Q. One of the point P is in contact with Q. Now, three different condition is given. Plate, always this coin is rotating with an angular velocity omega in clockwise direction always. But in condition 1, the plate is fixed. Condition 2, the base plate is moving right with a velocity 1 meter per second, and velocity, condition 3, the same velocity magnitude but the direction is opposite, means leftward. So what we have to find out? We have to find out the velocity of the center of mass of this coil and cylinder or coil, because if it is the cylinder, then one of the front view, it looks like a circle or coil. So for the coil and the cylinder here, actually a coin is also a cylinder with very small height. So we have to find out the velocity of the mass center C, and we have to also write down the condition of pure rolling. The condition of pure rolling, that already I have told you, that condition means no slipping. Means if we consider that a point is P, which is the contact point, and at the same time other contact point of the base plate is Q, then there is no relative motion between P and Q. Then it is the condition of pure rolling. Means velocity of these P point and velocity of Q point at a particular instant is same, if no slipping is there. Then how to find out these values? Plane of rotation is this. So omega can be written as perpendicular to this plane. Let's consider this is the xy plane of the paper, and perpendicular to that is the direction of omega. So omega can be considered as omega k. The magnitude of this omega is given 12 radian per second. The radius of this coin RCP radius vector, that is also given. It is downward. Let's consider it is the j direction. Direct downward is the j direction. So RCP to j. The value of RCP is given 20 centimeter or 0.2 meter in MKS system. Now the velocity VC is the velocity of P plus velocity of relative velocity of C with respect to P. Now this Vp, as per the condition of pure rolling, the same as the velocity of the base. So Vp equals to Vq, which is given as, for the first case it is 0, for the second case rightward direction it is 1, third case it is minus 1. So this is the value of Vp, that is equals to Vq, and omega that is given here, and RCP that we have written. Now we will substitute all these values in the equation. Now condition wise the values are VQ 0, initially it was static condition here, so substitute this, and omega cross omega, and this is k part only, and these RCP, first the direction of R, it is J, as I have told you, downward direction, that is we have considered J, and so I and K component is 0. So go through the vector product of this one and we are getting this value. So VC equals to 2.4 meter per second in I direction, because it is moving horizontal. For horizontal is considered I, vertical is J, and perpendicular to this plane is K. So our next case 2, here VQ is not 0, rather it is moving in I direction, rightward direction. What is this? I direction. So substituting that we are getting this value. And third case, it is minus I. If rightward is the plus I, then it is minus I is the unit vector, so minus of 1 meter per second. So this is all about the general planar motion, means two-dimensional motion. You notice that all these motions here in all the numericals, the motion in 2 dimension only. The references that I have used to prepare this video lecture is given here.
So we come at the end of our 24th lecture. In the next lecture, I will going to discuss the slider crank mechanism, that is also belongs to two-dimensional general or plane motion. So thank you for listening, and I will expect that in future also in the next and the subsequent classes you will attend. Thank you.